All right, this morning we're going to start our volume and surface area unit. Majority of this is going to be introductions and vocabulary and things like this. And I know you guys don't have this paper in front of you, so I've typed out most of the definitions and I'll post this on Canvas. If it helps you, if you want to take your own notes on a piece of paper, if it helps you remember better to write things down, you're welcome to do that. But most of this I'm just going to go through and set you up hopefully to be able to do the Math Excel assignment. And if you have questions, please email me or send me a Canvas message, or we can set up a time on Zoom if you need any help with anything on this assignment. So just introduction today. I'm just going to start here, a lot of diagrams on this. So we're going to be talking about volume and surface area, so we're going to use three-dimensional solids. So today's goal, we want to be able to identify, we're going to also name things called polyhedrons, and we're going to find number of faces, edges, and vertices for some of these figures, and we're also going to talk about nets and cross-sections on the back, all involved in the same topic. Okay, so 3D solid, here's your definition. It's bounded by, it can be flat or curved surfaces that enclose a single region of space. Now there's kind of two different sets here. Most of what we're going to focus on today are going to be the polyhedrons. So there's two categories of polyhedrons, and I'm going to kind of explain those below a little bit more clearly. Prisms and pyramids, but all the surfaces there are going to be polygons. Now, there's 3D solids over here. These are not polyhedrons, and that's where not all the faces are polygons. So here we've got anything that's got kind of a curve of some kind, like this is circular, this is a cylinder, a cone, sphere. If you've got circular surfaces that don't have a nice, it's not a triangle, it's not a rectangle, it's not a pentagon. If it's not a polygon, then we're going to fall into this category, which are not polyhedrons. Okay, so we're not really going to talk too much about these today. So the rest of this information you guys are going to see is to do specifically with polyhedrons, so either a prism or a pyramid. Okay, so just some vocabulary terms here and then a diagram. So a face is just any of these flat surfaces here that connect to form the polygon. So I'm going to grab my highlighter here. If you guys could see this in color, it would look a little bit better, but there's a face, and you can see there that's rectangle, maybe a square if we had it in person. We can't really tell from the diagram, but a face is just any of the flat surfaces. An edge, which is kind of darkened in this picture here, it's a line segment that is formed by the intersection of two faces of the polygon. So here I've got this face, the intersection is that line segment, so that's called an edge. And then a vertex is a point where three or more edges meet. So just as a little example, vertex is basically like, I kind of like to refer to it as a corner. So here's an edge, a little dotted line is an edge. This is an edge across the bottom, and they intersect in that vertex. All right, now we're just going to do a couple more terms here, split the difference, and then we'll talk about how to name these figures. So let me slide this back down so you can see. So I'm going to talk about prisms and pyramids. So prism, you're going to have two bases. So every prism has two bases. There are two faces that are going to be parallel and congruent to each other. And then what we call the lateral faces are all the other faces in the figure, and for any prism, those will always be rectangles, and they run between the two bases. Let me come down just below here real quick because I've got an example of a prism. So I have two parallel faces. There's a pentagon. There's another pentagon. They're parallel to each other. They're parallel planes there. And as you guys can see, all the other surfaces in that figure that run between the two, those are rectangles. So the rectangles are what we call the lateral faces, and then the pentagons are what we call the base. Now, for pyramids, you only have one base. So in this example here, this is the base. And then all the other faces are going to be triangles when you have a pyramid. And then those triangles, one of them, or sorry, all of them connect to each one of the sides of the base, but then instead of running interference between another base like a prism, you come up and they each come to a vertex and a point. So each one of those lateral faces is triangular. Alright, so then this blurb here just kind of explains how to name these. So they're named for the shape of the base or bases. So if you have a prism, you have two bases. If you have a pyramid, you have one base. Okay, so this says if we have two, we have a prism. If we have one base and the lateral faces are triangles, then it's a pyramid. So here, the base is a pentagon, so this is called a pentagonal prism. Here the base is triangular, so this is called a triangular pyramid. So if you've got two bases, you've got a prism. If you've got one base and all the lateral faces connect at a vertex, single point there, then you have a pyramid. Alright, so we're going to come down to an example one. And sometimes these can be tricky because just because you have a base doesn't necessarily mean the figure lies flat on the base like that example there. So what you're looking for is what shapes do you have, what faces are parallel, if any, do they come to a point, do you have any curves? So let's start there. So first of all, it just says determine if this is a polyhedron. So all the faces are polygons here, so this one is a polyhedron. And let me go back to the names in a second. This one in the middle, this has a curve. If you don't have nice flat shapes with straight edges, if they're not polygons, this shape here is kind of a weird curve. This is not a polyhedron because I've got that curve in it. Now this last figure here, I've got all my faces being polygons, so this is a polyhedron. Okay, so let me back up. We won't be able to name this one because it's not a polyhedron. Okay, now you're looking for two parallel faces, if possible, because we don't come to a point here for everything at a single vertex. Now, this is very tricky for people. The base there, though, has to be a triangle because none of the other two faces in the diagram are parallel to each other. So this we're going to call, because the base is a triangle, a triangular prism. And you guys can see the other faces in that figure are all rectangular shapes. So the lateral faces are rectangles, means we have a prism. Now, over here, remember we're not going to name this one because it's got a curve, so it's not a polyhedron. All right, over here, obviously all these points, or all these faces come up to a point, so it's easier for me to tell here that this is definitely going to be a pyramid. So you got to figure out what the shape of the base is. If you count the sides there, it's going to be 6 sides, so this is called a hexagonal. And since we all come up to a point, a single vertex, this is going to be a hexagonal pyramid. And then you guys can see here all the other faces in that figure are going to be triangles. In example 2 here, we're just going to see if you guys can go ahead and name these. Just identify, is this a pyramid or is this a prism? And then what we're going to talk about is finding the number of faces, vertices, and edges. Alright, so if you guys notice here, I do have a base. And honestly, it doesn't look like a rectangle or a square or anything, so it's just going to be a quadrilateral. And this is going to be a pyramid because all the other faces are triangles and then they come up to a single point. Now, in terms of counting vertices, faces, and edges, let's go first with the faces. Okay, so faces are just polygons. So we got the base. And then the base, if you notice, has 4 sides. So each one of those sides is going to connect up to a triangle. So I've got 4 sides here, so we should have 4 triangles. And then the one base, so the number of faces should be 5. Number of edges are the number of line segments that you're going to see there. So an edge connects a face with another face. So I've got 1, 2, 3, 4 here. And then 1, 2, dotted line, 3, 4 more, so this will be 8. And then the vertices are your corners. So where 3 or more edges meet. So I've got 1, 2, 3, 4, 5 vertices there, and that's all I have to identify. Let's come over here. This, let me count the shape sides. So I got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we got an octagonal. And I've got 2 octagons parallel to each other. We've got rectangles running in between. So this is going to be a prism. Okay, now for your faces, you've got 1, 2, the 2 bases, right? Octagon, octagon. Now, each one of these has 8 sides, so there should be 8 rectangles running around here connecting these. So I've got 8 rectangles and then 2 octagons, so we should have 10 total faces. Edges are the line segments, so 8 and 8 for each of the bases. So you've got each of those. And then we should have 8 line segments here with directors 1, 2, 3 going around 8. So I should have 24 total. So 8 around each one of these. Same thing around this base, and then 8 between each of the rectangles. And the vertices are the corners. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, and I would have 8 again around that. So we're going to have 16. All right, and that's all we have to do. All right, just a couple other vocabulary terms here. So a cross section, and this can go through any type of three-dimensional solid. It doesn't have to be a polyhedron. So you can see I've got a sphere here. Remember, that's not a polyhedron because we've got curved surfaces there. But what a cross section is the intersection of a plane. So you kind of see my plane here. So I like to think of a plane as like a sheet of paper. So if I slid a sheet of paper right through that sphere, the cross section is going to be the intersection of the plane and the 3D figure. So there, what's going to happen when I have that is it's going to be a two-dimensional shape. And so if you have a sphere, if I cross section, it's not angled or anything like that. The cross section there would just be a circle in my example. So that's all I'm going to ask you guys to do, is just identify what the cross section would be. And if it's helpful in any way to you, sometimes I kind of like to highlight the cross section to maybe help me see it a little bit better. So that's what I'm going to do in each one of these shapes. So again, this is just going to be a circle. This is just going to match kind of the picture. The plane's just slid a little bit higher up. This is a cone, and you guys can see again, you've got a circle. This shape is 1, 2, 3, 4, 5 sides. So this would be a pentagonal, and it would be a pyramid because I've got the lateral faces that are all triangles intersecting at a point. But you guys can see the cross section maybe a little better when I highlighted it is actually going to be the same shape as the base, so a pentagon. And then the last one here, this is a cylinder kind of turned on its side, so like a little soup can. Now this one I think is not necessarily, people think about this. If you were to slide a piece of paper through there, that shape actually is a rectangle for your cross section. As you can see, it might be a little easier to see if you look at my highlight there. And then the last vocab thing, we're just going to do all these introductions today, we're going to talk about is a net. Okay, so I have a little example in the definition so you guys can see this. This would be a pentagonal, because I've got 1, 2, 3, 4, 5 sides, a pentagonal prism in my example. The net is, in quotation marks, the unfolded. So if we had a physical 3D shape in front of us and we could cut it up and unfold it and lay it flat. So the net is a two-dimensional representation of a three-dimensional solid. So if you guys want to look here, you've got your two bases. And there are different ways to draw these nets. So not everybody's might be exactly the same. So you'll see the two bases, and then if I were to cut that out and fold that up, I could reform this three-dimensional shape. But you've got your two bases, and then you guys can see all your other lateral faces there are rectangular. So that's going to be your net. Now, what I have an example for down here, just a possible net is what I want you to try to draw. So I'm going to do a little sketch here. Now this is kind of a special case. So let me name this real quick. This is a rectangular, and then it's going to be a prism. Now the reason I say this is a special case is for a rectangular prism, the rule for your base is that it has to be two parallel congruent faces. And if I had like a cracker box, I could the top and the bottom could be the base, the left and the right could be the base, or the front and the back could be the base. The only situation that happens with is a rectangular prism. If it's any other shape, the faces that are bases will be, you know, a hexagon, a pentagon, whatever, and then all the other lateral faces have to be rectangles. But here, every single one of the faces is a rectangle. So you can really choose to use any as your base. All right, so totally up to you. I'm going to try to unfold this. So I'm going to look at the way this is situated in the paper here, and the bottom part of it is going to be 14 by 7. So I'm just going to kind of draw that, and if you guys look at my directions, it says label the dimensions. So this would be the 7, and then this would be the 14. So different ways you can draw this, but I'm going to kind of think about unfolding this box. So if I laid the front down, the 14 here, if I laid the front of this down, this side would be 20. And I could do that with the back as well, just as an example. So like think of taking the front and the back, laying them flat, this would be 20. Now one of those would have the top attached to it. So I'm going to have another, like here'd be my bottom of the box, here'd be my top of the box, so this would be 7. And then somewhere along the way here, we need to represent the two sides. So let me just think about folding those down from the base. So let's say that's the right side of the box, and this is not to scale, we're just trying to sketch this. This would be the left side of the box. So this would still be the 7, and then this would be the 20. And hopefully you guys could see if we folded this back up, these 20s would match, the 20 would match. If we folded it over the top here, the 14, this would be 14 here for my labels, and that would fold back into that box. Doesn't have to be perfect. You can see my lines are kind of shaky. Now, to me, I think the pyramids are maybe a little bit easier to draw. So my base here, this looks like a rectangle. Could be a square, but I'm not 100% sure because it doesn't say. So I'm going to say this is a rectangular, forgive me. Let's spell it right. Rectangular, this is a pyramid because all your lateral faces are triangles and they come to a point. So just to the best of my ability, I'm going to kind of sketch this base, which kind of rectangle. And then literally all you got to do, you just got to have a triangle off each side of that base. And then if we would fold that back up, this would be your 10 and then your 8. If we would fold that back up, then we would have the three-dimensional shape there. So a net is just a two-dimensional. We're thinking about taking it apart, unfolding it, and laying it flat. What would it look like? That's a net.